Ever wondered what would happen if one of the engines on a commercial airplane suddenly stopped working while flying at 35,000 feet? It might sound terrifying, but modern aircraft are actually designed to keep flying safely even if an engine fails completely. Today on Knowledge Hub, we're exploring how airplanes can fly with only one engine, the engineering behind it, and the safety systems that make commercial aviation one of the safest forms of transportation in the world. Most large commercial aircraft, like the Boeing 777 or Airbus A320, use powerful turbofan engines mounted under the wings. These engines generate enormous thrust by pulling in air through a fan, compressing it, mixing it with fuel, and igniting the mixture to produce high-speed exhaust that pushes the aircraft forward according to Newton's third law of motion. Under normal conditions, both engines share the workload and produce balanced thrust, allowing the aircraft to cruise efficiently across thousands of kilometers. But the key point is that aircraft are never designed to rely entirely on both engines at once. Instead, they are built with enough power in a single engine to maintain controlled flight if the other one fails. If one engine stops working, the airplane will immediately experience asymmetric thrust, meaning one side is pushing harder than the other. Without correction, this would cause the aircraft to yaw or turn toward the side with the failed engine. However, pilots counter this using the rudder on the vertical stabilizer, which produces aerodynamic force that balances the aircraft. Modern flight control systems can assist with this automatically, helping maintain stability within seconds. At the same time, the remaining engine provides sufficient thrust to keep the aircraft airborne, although it may need to descend slightly to a lower altitude where the engine can operate more efficiently with the reduced power. Aircraft are also designed with large wings that generate lift independently of engine power. The engines provide thrust, but the wings are what actually keep the aircraft in the air. As long as the plane maintains enough forward speed, the airflow over the wings continues to produce lift. To ensure this safety margin, aviation regulators require aircraft to pass extremely strict certification tests. During these tests, engineers deliberately simulate engine failures during takeoff and cruise to prove the aircraft can safely continue flying. One of the most important standards is called ETOPS, Extended Range Twin Engine Operational Performance Standards. ETOPS certification allows twin-engine aircraft to fly long routes over oceans and remote areas by proving single-engine capability. Depending on the certification level, aircraft may be allowed to fly up to 370 minutes away from the nearest suitable airport. In real-world operations, if an engine fails, pilots follow a well-rehearsed procedure to stabilize the aircraft. Next, they secure the affected engine, adjust thrust, and calculate a diversion route to the nearest suitable airport. Modern aircraft are equipped with sophisticated flight management systems that help pilots identify the safest airport and optimal flight path. Meanwhile, the aircraft's redundant electrical and hydraulic systems ensure that critical functions continue operating. In fact, many aircraft systems have multiple independent backups specifically designed for situations like this. Because of all these layers of engineering, flying on one engine is not an emergency that immediately threatens the aircraft. In many cases, the aircraft can continue flying safely for hours before landing. In fact, engine failures are extremely rare, and modern turbofan engines are among the most reliable machines ever built, capable of operating thousands of hours before requiring major maintenance. So the next time you look out the window and see those engines, remember, the aircraft doesn't just rely on them blindly. It's designed with redundancy and aerodynamics that allow it to keep flying, even if one engine stops working completely. If you have enjoyed learning how aircrafts are engineered to remain safe, make sure you subscribe to Knowledge Hub for more deep dives into the technology that powers our world. And as always, stay curious.